Welcome to the IPMWORKS e-learning modules. My name is Nicolas Munier-Jolin. I am from INRAE in France. And this video is part of module number 3 on integrated weed management. And we will address the biology of weeds. We will discuss the diversity of traits, explaining the weed community demographic in integrated weed management-based cropping system. Weeds are many, with many species and different life traits, different biology traits. And the knowledge of the variability of traits across weed species is something which is very important to understand how weed communities are sensitive to the measures adopted for weed management in IPM. So here we will address a list of traits, biological traits that vary a lot across weed species. And we will start with the life cycle and the taxonomy, with an example which comes from France, sorry, my country, where this is an example of a large regional survey in arable fields where we listed the species found in the fields. We found a total of 152 species in the region, in arable field. And you can see here that we can distinguish annual weeds, which are the more frequent, but we have also pluriannual and perennial weeds. And we have dicots and grasses, and one species that was a pteridophyte. So the dicots and grasses might have different sensitivities to herbicides. We have herbicides that are targeting more dicots plants, and herbicides that are targeting grasses, even though, of course, there are also some herbicides which with a large spectrum. And annual weed species survive in the environment, in the fields, by the dissemination of seeds. So most often annual weed species produce many seeds, many little seeds, and these seeds are long living in the soil. So they produce the soil seed bank, and the soil seed bank is the potential for the emergence of new weeds in the next crops, in the next years. Pluriannual and perennial weed species, they survive in the environment by the different organs, underground organs, such as rhizomes and bulbs. And because of this mode of multiplication, most often pluriannual and perennial weeds, they have a patchy distribution in the field. So this is interesting because there is then a big potential for local precision spraying of herbicides, and a very big potential for reducing the amount of herbicide used thanks to this technology of precision spraying. But the bad aspect is that for most species, because of those underground organs, there is quite a low efficiency of mechanical weeding on those perennial and perennial species. The second biological trait of which is important to consider is the growing season and the germination period. Annual species, they survive in the fields and they produce seeds when they germinate and emerge soon after crop sowing, and when they are able to maturate seeds before crop harvest. And you can see on the right side of the screen that you have a list of species here, about 20 species, and you have the optimal period of germination of those species. This is adapted from Montaigu in France, so this period of germination and emergence might vary a little bit across countries and regions throughout Europe. But anyway, the main message still is applicable everywhere in Europe. So you can see that you have some spring emerging species such as H2020, whereas, for example, blackgrass Alopecuris myothyroides is mainly emerging in October in France, a little bit in November, and a little bit in spring, but the main emergence period is in the autumn. You have some species that are able to germinate and emerge in the late spring, such as, for example, Chenopodium album, which is typical summer wheat species infesting summer crops. And you have a few species that are able to emerge about all over the year. For example, the grass species Poa annua is able to emerge all over the year. So we know that the sowing date of crop is the main driver of weed community in this specific crop. So if you maximize the number of different crops and the number of different growing seasons of the crop in the crop rotation, we know that this reduces the frequency of seed dissemination for a given annual species, and this is interesting to reduce the weed pressure, and therefore the need for herbicide. Of course, this effect of having a diversified crop rotation with many growing seasons in the crop rotation will have less efficiency for species that are able to emerge all year long. So in any crop, whatever the sowing period of this crop, such as, for example, Poa annua. Then we have the duration of the persistence of viable seeds in the soil seed bank. In annual wheat species, all seeds are able to survive several years in the soil, but the annual rate of depletion of the soil seed bank varies quite a lot across species. You can see here in this figure the evolution of the soil seed bank over 4 years for 17 species. We have 17 species here represented with the list on the right side here, and you can see that we start at the beginning with 100% of living seeds in the soil at the beginning. After 1 year, we have less decrease in the amount of viable seeds in the soil seed bank, and less 2 years after, and after 3 years of burying in the soil, again a lower proportion of viable seeds. As you can see here over those 17 wheat species, that you have two groups of species. On the left, you have a list of a few species that have a short persistence of seeds in the soil seed bank. And those species, such as Avena fatua, Alopecuris myothyroides, Callium aparine, have a short persistence seed bank. So those species, they will be very sensitive to the crop rotation and to the plowing, because the plowing that bury seeds during 1 or several years, and this and if for those species with a short persistence of seeds, the amount of viable seeds, when you will use the plowing again and bring back to the soil surface some seeds, a high proportion of those seeds will be dead after 2 years or 3 years. So those species will be very sensitive to crop rotation and to plowing. Whereas all the species here, such as Chenopodium album, Sinapis arvensia, H2020 IPMWORKS, are species that are known to have a longer persistence of seeds. seeds able to remain viable in the soil seed bank during many years, and those species will be less sensitive to crop rotation and to plowing. And we can see that many of those species that are in the first list of short persistent seeds in the soil seed bank are very often overwintering species, such as, for example, Alopecia myothyroides and Gallium aparine, which are typical weeds infesting winter cereal, winter wheat, and winter barley. These species will be quite highly sensitive to propagation and plowing, whereas many long persisting seeds are from species that are emerging in the spring or in the summer, such as Phenopodium album and Sinapis album. Next, traits of weed biology, which is important to consider, is, of course, the competitive ability. Across the diversity of weeds, you have weed species with a weak competitive ability. Very often, these are small plants with small leaf area. It can be plants that remain small because they have short cycles. And it can be also that they are weakly competitive because the seeds and the seedlings are small, so they need some time to become competitive against the crop. Whereas, of course, the weed species with a high competitive ability, they tend to be high plants, which large leaf area, long life cycle. They can have large seedlings. And also, it can be also a habit of climbing that makes that gives the opportunity to weeds to climb on the crop, and at the end of the season to be over the top of the crop and come to the sunlight and become very competitive. And this is, for example, the case for Gallium aparine, which is a very competitive species. You have here a ranking of a number of weed species, very frequent and in arable field crops, and there is a number of the density that is able to induce 5% of yield loss in winter wheat, according to the literature. And you can see, for example, that 5% of yield loss in winter wheat can be produced by about more than 100 plants per meter square of Viola tricolor, or 70 plants per meter square for Myosotis arvensis, whereas 0.5 to 4 plants per meter square of Gallium aparine, so much less number of plants, can produce the same level of yield loss. One aspect which can be highlighted here is that competitive weed species, when they are very high with a long growing cycle, they might have some ears and flowers that can be above the crop canopy at the end of the growing season of the crop. So this might be interesting for the technique of head cutting of those weed species to reduce their seed production. Of course, this is important for small plants with short cycle, where the technique is absolutely inefficient. Next trait of weed biology is the seed size. It's interesting to consider because the seed size might be related to the ability of weed seeds to germinate and produce a seedling from a deep soil layer. You can see here a relationship that was established by Benvenuti and Mazzancini quite recently. The relationship between the size of the seeds in terms of grams for 1,000 seeds and the maximum elongation of the seedling, hypocotyl seedling before emerging on the soil surface. And you can see a clear tendency that larger seeds can produce longer hypocotyl, so are able to emerge from a deeper layer of soil. So meaning that species with small seeds might be more sensitive to burying in deep layer of soil, so more sensitive to plowing, whether some species with large seeds and high seed weights, for example, Avena fatua is a species which is very well known to have large seeds and to be able to germinate and emerge from quite deep layers of soil, for example, at 10 to 15 centimeters deep. And finally, I will say some words about the duration of the cycle, the life cycle of the weed species. We have some species with short cycle and species with long cycle. Species with short cycle are very often able to produce some seeds on stubbles, on the short time of stubbles, after the harvest and before the sowing of the next crop. In some crops, they are able to escape competition by producing seeds quite early in the season, so before the crop is having an intense competition for light and nutrients. And in grasslands, when the short life cycle species can escape mowing, they'll be able to produce some seeds before the mowing of the grassland. And of course, in short cycles, which species seeds are shed before harvest. So there is no possible option for collecting the seeds at harvest with the proper equipment that I will present thereafter. But the good thing is that those short cycle plants are very often small plants with weak competition against the crop. Whereas for the plants with a longer life cycle, very often there are competitive plants, large plants, high plants. But one aspect is when seeds are still on the weed plants at the date of crop harvest. If you have a specific equipment, you could think of collecting those seeds at harvest with the combine harvester and avoid the shedding of those seeds and avoid the replenishment of the soil seed bank. So there are some proper equipment either to export seeds outside the field or to destroy and kill the seeds before putting those seeds back to the soil. But if they are dead, there is no risk, no potential for germination and emergence in the next crop. Finally, rooting type is something which is important because related to the sensitivity of weeds to mechanical weeding. You have different types of rooting, of course. Pivot rooting, which is presented here, which is the case for many dicot plants. Those pivot rooting plants are very often more sensitive to mechanical weeding, at least at young stages, of course, because at later stages, no weed plant is sensitive anymore to this kind of mechanical weeding with springtime harrows. Whereas grass weeds most often have a different rooting type with fasciate rooting, and because of small roots emerging very early in the season, those species very often have less sensitivity to mechanical weeding. So thank you very much for your attention. This was a short list and discussion about life traits of weeds. diversity of life traits of weed species, and relationship with techniques for weed control in the framework of integrated weed management.